All right, let's take a look. What we're going to do is we're going to do area, and let's start off with something really easy. What's probably the first thing? You remember when you guys did area back in the day when you were a kid? What was probably the easiest area formula that you did? Do you remember? There's a big hint right there. Yeah, square probably, or a square is a more specific type of what? It's a rectangle. That's right. So here's a rectangle right here. So um, a lot of times they use length and width, don't they? It doesn't really matter which one you call the length or the width. Okay, one is the length, the other is the width. Or you could call them, instead of length and width, let's do something a little different. Let's not call that length, and let's not call that width. Let's call it, and I'll actually do it down here, let's call it base and height. Okay, you can call it the same thing. Now, most of the time you learn the area of a rectangle is length times width, right? That's how most of us learned. I learned it that way. I taught it that way, for years and years and years. But we can also think of it as base and height. Now, here's something that's important. I don't think we discussed this, did we? We didn't do area at all yet, did we, in that other lesson? Okay, because I taught it sometime this year. It must have been in one of my other classes. But when you have a base and a height right there, this is what's really important about this, is that right there has to be a right angle. In order to have a base and the height, when they touch each other, the base and the height have to be a right angle. What's a fancy math or geometry word that we used? When you have two lines that form a right angle right there, we said those two lines are what? Perpendicular, okay? We didn't discuss that? We didn't do perpendicular in here? Yeah. Yeah, I thought we did. I thought it was in here we talked about this. Okay, yeah. So anyway, the base and the height would be perpendicular to each other. So if I wanted to find the area of this, which is a rectangle, a square is the same way. Sometimes they'll use a different formula for square, but there's really no reason to think of even a completely different formula. It's really the same thing. I try to think of I want to know the least number of formulas that I can possibly get away with, don't you? Because it's too much, too many formulas is just too much to learn. So I remember it like this. The area of a rectangle, you could say length times width, or in this case, instead of length and width, what is it? Base times height. I don't know why I'm writing up a hill, but that's what it is. So that's the area of a rectangle. Square is the same thing. Sometimes they'll say, some books will say, okay, if it's a square, we'll call one of the sides S, so the area of a square is S squared, right? S times S. But is there even really any reason to do that? Not, because if this is a square, I could just call one the base, one the height, even though they happen to be the same thing, and just realize I multiply them together. All right, would you agree with that? That's pretty easy, yeah. Let's get rid of this little bit right here. Let's keep the rectangle. Now, the other thing that we're going to do is the area of a triangle. Let me do this. Watch, let me start from this. Oh, stop doing it. This pen's kind of sensitive. Boom, right there. Okay, and I'm going to go to this. Did we do that? Yeah, I think we did this in another... Yeah. 1G, is that what it is? Oh, okay, that's right. We just did that because we were talking about circumference and all that kind of stuff. Well, we didn't do area, though, did we? We just did... Oh, we did area of a circle. Oh, yeah, we did area of a triangle, too, didn't we? And area of a rectangle. Yep, and they use length times width. Okay, okay. Gotcha. Now I'm on track. Let's go through this anyway. So if I do this is called a diagonal right here. If I drew the diagonal to this rectangle, what have I formed? I've formed two what? Two triangles, right? So I got a triangle here and I got a triangle here. Well, if this one big rectangle was the base times the height, this is how much of the rectangle? It's half of it, right? So it's the area of just the triangle is what? It's 1/2 times the base times the height. Okay, that should sound familiar because we talked about that the other day. I thought we had talked about it. So that's the equation for area of a triangle. That's kind of review, I guess. Let's move on. And we talked about this before, but let's just touch on it real quick here. Actually, let's not. We talked about it before. If you want to look at it, you can go look at that lesson where we talked about the acute triangle. Remember we drew from the top straight down to the bottom, right? I almost hate not going over it, but I don't want to do, I guess I could do nice lines. It shouldn't take any longer. All right, so, yeah, like I said, nice lines. Let's try it one more time. Let's go like this, and let's go like this, and let's go like like that. And we'll squeeze this baby in right there. Okay, there we go. How's that? Close enough. That's an acute triangle. If I wanted to find the height of this triangle, it's not one of the sides like it was on a right triangle. It would be from here straight down to here. All right, it's perpendicular. That would be the height. From here to here would be the base. That's just quick review. All right, and one other one. Do you remember this? What other triangle did we have? This is an acute triangle. We already talked about a right triangle. What was the other triangle? Obtuse triangle. So let's draw an obtuse triangle. So let's go here. Oops. Let's try this again. There. Let's go there. And let's go to there. All right. Now, what do we do to this to find the height? Let's go red again. Remember this? We extended it out. Oops, I made that side red. That's okay. And then we drop that thing down right there. So now this up and down right there, that's the height. Even though that's not one of the sides of the triangle, it's still considered the height of the triangle. Make sense? What is the base? Is it from here all the way to there? No, it's just the part of the triangle. So the base is just from here to here. Got it? All right, so again, it's just 1/2 the base times the height. You find the base, find the height, take half of it, multiply them together, take half of it, and you're good to go. All right. That's all review. Let's see what else I want to do here. Let's pause this for a sec. All right, let's take a look at this. This is not just a simple, rectangle or square or triangle. It's a three-dimensional figure. And what do you think they call this? It's in the book. It's a cylinder, right? So it's a cylinder. And what we're going to do is we're going to find the area of this cylinder. Now, this is three-dimensional, so it's not just one area, is it? It's actually a combination of things. Look, you've got the top, don't you? You got all this right here. And what else do you have that's close to the top? It's not just close, it's exactly the same as the top. What else is exactly the same as the top of this? The bottom of it, yeah. So you got the bottom. You with me? That's supposed to represent shading in, okay? So you got the top that's shaded, and you got the bottom that's shaded. What else is there to the cylinder? You got the top, the bottom, and I don't know, what would you think of? Think of a Pringles can. You've had Pringles, right? Okay, think of a Pringles can, and you've got the top, you got the bottom, and you got all the rest of it. What would you call all the rest of it? Sides, yeah, that's what I would call it. In fact, they give it a little fancier name. They call it the let's see, the lateral surface area. They call it lateral. What's up with that word? Why lateral? Because what does lateral mean? You ever do I don't know, you ever play sports where you do a drill? Like in basketball, I played basketball, and you did this. We called I don't know, they call it the lateral movement. I don't know, move lateral. They told you move lateral, and you go side to side. That's what it is, okay? So you're standing there, and you shuffle this way, and you shuffle this way. Call that lateral drill, I guess, or move laterally. It means side to side. So lateral means side, okay, basically. So when we talk about the lateral surface area, we're talking about the area of the sides. You with me on this? All right. What I'm going to do here, now this may not translate very well to YouTube because nobody can see me, but I want you to picture this. I'm taking a piece of paper and I'm twisting it around so it makes a cylinder. You follow me? So if I want to find the area of this entire cylinder, you have to pretend that there's a top and a bottom, okay? So there's a top and a bottom. What kind of shape is the top of this? So what is it's a circle, isn't it? So how do you find the area of the top? Yeah, that's right. So it's pi r squared. That's the area of the top. Now you've got the top and the bottom, so what would you do? You'd add them up, wouldn't you? Find the top, the bottom would be the exact same thing, and you just add them up. So you can find the top and bottom very easily. It's the sides. The sides are the ones that are a little bit more, let's kind of, I don't know if I can shade it in or not, but see the sides, but this is on a two-dimensional surface, so it's not just straight across like this. It goes all the way around, doesn't it? All right, so let's picture this. All right, look at this piece of paper. I'm folding it like this. You've got the top, you got the bottom. But now what we want to do is we want to find the lateral surface area. Basically, the area of this whole sheet of paper is what we're doing. So guess what we can do? We can cut this straight down the middle. All right, so if you're ever watching this, right, we can cut this straight down like this and then open it up. And what does it open up to? To a rectangle, right? It opens up to a rectangle. So let's think about this. So we take, let me get my, it basically opens, oops, sorry, I need the square thingy. There we go. Okay, watch. It opens up like that. You follow? All right, so we cut it right down the middle, and we unfurled it, okay, whatever you want to call it. So this is still the height of it, right? But it goes out this far. Now, what about this distance? What is this distance from here to here? Oops, that's a terrible line. Well, I'm trying to draw a straighter line. Think about it. That length right there, what is it in reference to this figure over here? Say it, Aubrey. You're doing it with your finger. You're doing it right, but give me the word. So watch. This right here, that's what you're doing with your finger, right? That right there is that width, okay, or that base, if you want to call it that. What is that? This is a circle. Give me the fancy geometry word. We talked about it the other day. It's the distance around. It is the perimeter of the circle, or it's the circumference. That's right. It's the circumference of the circle. But you're right, Aubrey. We're going to use that word actually. We're going to use perimeter. But it is the circumference of the circle, isn't it? So that distance right here, from here to here, right, let's go down the bottom, from here to here is actually the circumference, we'll just put a C for circumference, of this circle, isn't it? Or you could think of it as the, what was the other word you used? Perimeter, right. Now watch, I'm going to put a little phrase here because we're going to use this quite a bit. Or you could think of it as the perimeter of this circle, or the bottom, or the base. That's what I'm going to use. I'm going to use that phrase a lot, the perimeter of the base. Now that's really important. So how do you find the lateral surface area? The lateral surface area is the perimeter of the base, which is this distance right here, times what? What is it from here to here? It's the height. It's the height of the cylinder, isn't it? Okay. So let's write a formula. So lateral surface area, since that's in red, let's go back to red. So lateral surface area is equal to what? The perimeter, I'll just put P, of the base. So it's the perimeter of the base. In this case, what is the base? It's a circle. Okay? Not every single picture will it be a circle, but in this cylinder, the base is a circle. So it's the perimeter of the base, what? Times the height. Good. That's the formula that I want you to learn. Right there. Lateral surface area. I know it's kind of ugly, it's all inside of there, but there you go. The lateral surface area is equal to the perimeter of the base times the height. Do you understand how we got to that? All right. Now, when I say the lateral surface, if I ask you to find the surface area of this whole entire thing, it's not just the lateral surface area. The lateral surface area is just the sides of it. Okay? But you also have to include, what did we talk about earlier? The top and the bottom, right? So the top and the bottom. So we've got the area of the top, we've got the area of the bottom, and then we have the area of all the sides. That's the lateral surface area. So what do we do with all three of those when we're all done? Add them all up, and you got the total surface area of the whole entire cylinder. Make sense? All right, let's do a quick example. We got less than 1 minute. We'll do a quick example, and we'll see how to do that. All right, now we're going to find the area. They're going to find the total surface area of this cylinder. All right, so first thing we do is we find the top and the bottom. Sometimes I like to do that. I like to write top and bottom. And what is the top and bottom? It's a circle. So what's the circle? It's pi r squared. So let's do that. It's just pi and then 5 squared, which is what? 25 pi. Let's just keep it 25 pi. Let's not even put it in a calculator yet. All right, so 25 pi plus what? Another 25 pi, which gives you what? 50 pi. So let's hang on to that just for a second. I'm not going to have time to finish this, am I? I better go on to the next one.